Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities live and with audience participation. And now, here is your host, Jonathan Levy.
Hello, everybody. Welcome to another awesome episode of the Infill Podcast. I'm joined today by another wonderful guest, but before we get into that, I do need to thank our sponsor, Octo Everywhere, and do one of my favorite sections of the podcast we do every week, which is called What's Printing, Jonathan? Brought to you by Octo Everywhere. You can see on one of my Bamboo Lab printers, which still works even in LAN mode with Octo Everywhere, so that's pretty exciting. I'm able to quickly view and see that one of my prints just finished, and I've been too busy today to start a bunch of prints, but what I like is with Octo Everywhere, I can connect my slicer, in this case Orca slicer, directly in to Octo Everywhere instead of the local IP, and I can just fire off a bunch of prints. There's a link in the description. You guys get a free $25 credit from Octo Everywhere. And I see that my volume is very low. Unfortunately, I don't know that I have a way to fix that. Let me fix it before I introduce our wonderful guest. Yep, you guys were right. Here we go. There we go. All right, this microphone is always very quiet. So, Octo Everywhere, thank you. On to today's guest. Today we are joined by Rachel Minard of 3DXTech. She's a product manager who's been involved in developing some really high-performance 3D printers and 3D printing materials. Rachel, welcome. Glad to have you here.
Hi, it's great to be here. How are you?
Fantastic. I hope I did okay on the bio.
Oh, yeah, absolutely. Yeah, I've done a little bit of everything here, so it's a little chaotic.
Very cool. Now, I want to get into all that, and I want to especially ask a lot of questions about composite materials, because you guys are known for your composite materials. Before I get into all that, tell me about your journey with 3D printing, how you got started, when did you get into 3D printing?
Yeah, absolutely. So started way back in high school. I took a couple courses for actually CNC machining, but we had a little dinky printer. I think it might have been even a MakerBot just sitting in the corner of the shop, and I fell in love. I loved just the creation, just the additive manufacturing aspect of it, and just what felt like at the time completely unlimited capabilities. So I started learning everything I could on my own, and then I actually went to college for product development and plastics, but had a special place in my heart for 3D printing. Our university that I went to actually had a 3D printing lab, which is amazing. So I ended up working there for about 2 years. We actually bought 3DXTech Materials. That's how I heard about this company. And then about a year later, I ended up actually coming into this company in a design engineer role, and now I'm here.
That's really, really cool. Now, I perennially, my audience knows, live with regret that I didn't study product design and engineering in school. You said product design, but also you came in as an engineer. Describe that degree to me. Like, how does that work? Is it a little bit of design, a little bit of engineering? Because it sounds like you got a little bit of the best of both worlds there.
Oh, yeah. So the university I went to, a little college called Ferris State University in Michigan, they do a really cool hybrid. They try to balance it. So they call it 1/3 industrial design, 1/3 mechanical design, and then 1/3 just everything else. So plastics, metals, everything material design focused. So for me, that was a lot of prototyping, a lot of designing on napkins. Our final project in the actual degree was taking from a napkin design all the way up to quoting for tooling and annual use volumes and everything like that. So they try to make it as realistic to real life and what you're going to deal with in industry as possible. And that was a huge benefit to me. I loved kinematics. I loved the mechanical side of things. And then they let me, really shift into the plastic side of things because that was my specific focus. Whereas we have a lot of guys who are more in automotive, wanted to get more in the metal side of things. But for me, I really wanted to stick in the 3D printing side, and it was a huge benefit. So.
That's so cool because you often hear, about a separation. And I had a friend early on in my career who also, he was a software developer, but also got, in addition to the engineering component, a lot of design and entrepreneurship and stuff, because his university had the approach like, hey, even this was 20 years ago, they're like, you're going to, at the time you're going to be replaced by globalization and international workforce. Today it's AI. Like, so, your unique value is going to be able to pair design and pair. So that's cool. I'm a little jealous of that degree. That sounds awesome. And then it sounds like 3DX Tech is your first job out of college.
I did a short-term quality role in an automotive company, but for me personally, my goal was always to get more into the additive manufacturing space, just because it's so dynamic, it's so fun, it's constantly pushing in what feels like dozens of different directions at the same time, and it's just vibrant. You meet so many interesting people, hence where I am today having this
Yeah,
conversation. So,
likewise. So I didn't realize when you sent in your bio, and by the way, folks, feel free
Mhm.
always to ask questions, and I will, here, I have a little button that I can push, and it tells folks, feel free to ask questions. And I will
Perfect.
ask them when they come up naturally in the conversation. Uh, I didn't realize that 3DX Tech, I know you guys for your polymers, especially a lot of the high
Mhm.
performance engineering materials. You told me about a HT2 printer that you worked on at 3DX Tech. I didn't know that existed.
Yeah, so that definitely is a printer that's more in the military aerospace side of things. It's a huge industrial grade printer. We basically just we wanted to see what we could do and push performance as much as we could to really accommodate our portfolio of materials, get as much of those as we could, and just really tailor it to the industries that we like to really push limits in, so military aerospace. But that was a really fun jaunt for me. But I got so obsessed with the polymer side of things and the filament side that I just couldn't help
Right.
but shift my focus over into this, because at the end of the day, the printer was incredible, very, very cool. But, it's driven by the materials that you're trying to get and the applications you're trying to push with those materials. So I
Right.
could not help but go back to my roots in the polymer side of things. So,
That's so cool. I think it's also really cool. I think a lot of us, when we think about polymers, we think you need to
mhm.
have like a PhD in chemistry to be working on these polymers. And that's, I mean, I don't want to discount you, but I don't remember you putting a doctor in front of your title. I think
Nope.
it's really, it's eye opening, and I think important to
Mhm.
emphasize for anyone looking to get into this. You don't need to do an 8-year PhD
Mhm.
to do really really cool stuff in polymer science, which is refreshing.
Yeah, absolutely. There's a learning curve. I will not deny that polymers are complex. But yeah, don't let it deter you. Don't feel like like you said, have to take an 8-year PhD track to do this. For us, we partner with our suppliers who have, combined 75 years of experience
Wow.
for, specific polymers. So the industry is very, very forthcoming with information. We all want to learn, we all want to share, we all want to push technology to where we dream it will be.
Right.
That's the big thing. So obviously, know your things, be willing to learn always, because there's new things coming out every day that I have
Totally.
never heard of. But don't let that deter you. Feel free to, just play around, see what there is, and lean on the people that have specialties. I met a man the other day who had a PhD in polycarbonate specifically, only
Specifically.
polycarbonate.
That's
Yes,
very
and
interesting.
it's incredible. It's incredible, and it makes sense because there's a lot of different variants and different ratios that you can get in the chemical balances. But you lean on those people who have those just
Sure.
desperate obsessions with a particular type of material, and you use that to really leverage the more wide range portfolio that we have, for example.
Okay, so let's get into that, and I'm excited because it sounds like you're probably one of the first people I've had on the podcast that I can just feel completely comfortable geeking out on specific materials, and we can go filament by
Hmm.
filament, and we can talk about them. Uh, First thing is, I want to kind of understand. I mean, you guys answered this for me because you guys were kind enough to send over
Hmm.
some materials for me to play with, but
Hmm.
glass fiber versus carbon fiber. You're,
Hmm.
I won't say one of the few, but many, many different filament manufacturers are now offering carbon fiber. Not a lot of them
Hmm.
are offering glass fiber materials.
Hmm.
Fill the audience in. What's the difference? Why would you go with one versus the other?
Yeah, absolutely. So it really depends on your application. A lot of these questions are going to be application dependent. But the main things for me, carbon fiber tends to be a little bit more lightweight, a little bit less dense, which is a big benefit in things like aerospace or drones, things like that. In terms of glass fill, that is a little bit more I don't want to use the term across the board chemical resistant, but some applications you can't use carbon because you might have galvanic corrosion, things like that that can occur if you have like
Uh-huh.
contact with metals, stuff like that. So I really find that the glass fiber is very robust, very impact resistant, very strong, adds that rigidity, of course. The carbon fiber I find tends to be, you also have the conductivity aspect of it in some
Right.
level, which is a big benefit. So there's a lot of different ways you can look at it. I see glass fiber as a really just straight up, you know exactly what you're getting into. It's rigid, it's strong, it's impact resistant. Carbon fiber is a little bit more specialized and can have huge benefits for your specific application, but can also come with some unexpected challenges depending on if you say you don't want conductivity, things like that. So, and
Right.
obviously there's a price difference as well.
There's the conductivity component.
Mhm.
Obviously, price is a thing.
Mhm.
There's this interesting kind of like paradox
Mhm.
where on the one hand you're adding rigidity, and I always get confused about, you have rigidity, you have tensile strength, you have Young's modulus. So when
Mhm.
you're adding fibers, either carbon or glass, you're adding rigidity, and a lot of people think because they associate carbon fiber, aerospace, F1, they think
Mhm.
you're adding strength, but actually you can be decreasing the strength of the material in certain
Yeah.
ways. Fill me in on that.
Yes. It generally will become more brittle with the more filler that you have into it across the board because the molecular chains are sort of disrupted from their typical spaghetti-ish interlocking mesh that they have once they're cooled. So you add fillers to it, and that starts to kind of disrupt um, that intertangling that can happen. So you will start to have a little bit more brittleness to it. You'll have areas where, say, there's filler because you never get 100% across the board uniform dispersion. So you'll
Huh.
have some areas where there's a little bit more filler in one section than another. That becomes a stress riser because the polymers can't intertangle there, can't connect. There's a little bit of almost like a sheet of ice is always how I think about it. Not the most scientific metaphor in the world, but it becomes an area where there's more potential for the physical part to have a little bit more of a break to it. So that can be something to think about when you have really high impact or, like you said, flexural loading over time or just cyclic loading. That can be a big factor to this. So it's really important to think about those kind of things.
So is it always the case that if you take the pure material versus the carbon, I mean, obviously we said there are benefits to adding carbon fiber, but
Mm-hmm.
is it always the case that if I want absolute strength and impact resistance, I should always go with the pure version of that material, like pure nylon or pure
Hmm.
ABS?
I don't want to default to it depends on your application, but it really truly does. If you have a thin part that is more, like a cover style, I have found that that will tend to want to crack or, break with impact resistance a little bit more readily than, say, an unfilled. But if you have
Interesting.
a thick part that's going to be under compression for long periods of time, has heat cycling, you'll probably want to go with the filled version just for that increased compressive strength, that increased heat resistance, and the dimensional stability and heat cycling. So, we see some materials, even if they're higher performance, that maybe don't have quite as much continuous use temperature resistance that, say, adding carbon fiber would fix that issue. So you'll have a little bit more deformation, a little bit more pinging of the part over time. When you add a filler to it, that really takes that away. But if you
Huh.
have, a thin part that's going to be flexing, you might not want that added rigidity to it.
Okay. Wow. So it's never as simple as one
No.
would think. I
Yeah.
think I'm pretty good at choosing the right material for the job. I've done a
Mhm.
lot. I've done a number of videos about this.
Mhm.
It's also, this is my day job, right? To like learn this stuff,
Yeah.
and I like to say regurgitate it, baby bird it back to my audience. But that's years and years and years of having access to experts like you
Mhm.
and other filament sponsors. And I'm wondering if there's a resource or a tool that you guys offer, or just, rule of thumb kind of thing, where it's like someone just commented, Spectra said, I'm thinking of printing some Mark 3S parts out of ABS glass fiber or ABS carbon fiber. Like, how do you approach, okay, I have this, without the 10,000 hours that you and I, maybe not 10,000, have, how do you approach if you're getting outside and expanding your horizons to, okay, what do I choose the right filament for the job?
Yeah,
That's a
absolutely.
huge
Well, I
question.
think yeah, absolutely. And I certainly don't get it right every time. But I think one of the first steps that I always go through when we get, say, emails, a lot of the emails that we have for applications actually do come to me personally. So, feel free to send in questions if you have any for really cool projects. But so what I usually do is first I ask what equipment you have to work with, because that can be a limiting factor on what materials you can
Good point.
process. And then once we get there, let's say you have something that has almost no limits at that point. We will then move into what your specific application is with as much detail as possible. So temperatures that it's going to see, chemicals that it might interact with at some point, UV, water, everything can impact things like this. So you want to just get as much of a scope of your project as you possibly can. And
Yeah,
then when you get into that, then you can start with the base resin properties is always very, very important. Start with the
sure.
properties of the base resin. So like ASA and its UV resistance, you want UV resistance, lean on that. And then if you also need dimensional stability and compressive strength, then start looking at fillers. That's always
Right.
the kind of walkthrough that I look at. And obviously can be cost prohibitive sometimes, but sometimes you just got to get it printing and you just got to put it in and prototype it and see what breaks.
That's interesting. I wonder, I won't say who said it so that you can feel free to disagree, but I once asked someone at another filament company, and I said, what's the kind of guiding principle? And they said, look, we were talking specifically for industry and engineering. And he said, look, the biggest thing needs to be budget. In a perfect
Mm-hmm.
world where budget was not a thing, like he said, when we do something in the factory, everything is printed out of, I won't name the exact filament, but like
Mm-hmm.
the equivalent of Bamboo Labs PPACF, like the highest
Mm-hmm.
grade metal like strength. He's like, because no matter what I need, and I'm sure he didn't, we were talking about industrial applications. So as you said, like UV
Yeah.
wasn't a consideration, but that
Yeah.
stuff will just kind of survive anything. But he's like,
Yes.
then you go down. But it sounds like you have a kind of more bottom up approach than a top down of like, okay, you know what I'm saying?
Mhm, and absolutely, if your budget is limited, 100% drive to your budget, particularly if you
Right.
think you're going to have to prototype a few iterations. It's primarily just from the engineering perspective, in terms of like the creative side or the project driven side. But of course, budget is king at the end of the day with
Totally.
things. You can't drop a
And
few
you guys
thousand
make
dollars
some like
on
really exotic filaments. I'm pretty sure you guys make like a Peak, an Ultim. There's some pretty wild
that.
stuff in the catalog.
Oh, we have some filled peaks and pecks as well. So it definitely can get very exotic, very chaotic in a good way, just because you're getting to those upper limits of what a lot of printers can handle, and then also the upper limits of kind of like you said, you can put it pretty much anywhere and it'll be
Right.
okay. So that's always very fun. And you don't want to jump right to those every time, like you said, driven by budget.
Right.
But finding that balance there, it's a little hard sometimes to bring it back from knowing that we have our 1010 and our PIs, our peaks, our pecs, and bringing it back, saying, what do you actually need though to be safe, have a safety factor in your application because you don't want unexpected failures or long-term damage. But what is the minimum that we can get by with, depending on your budget. So
Right. I like to think of it, I think I kind of go through the same process you do, but less holistically, where I'll think of like, what is my headline constraint? So if my headline
hmm
constraint is like I did something for my son's daycare, which was a gate bump, And literally the
Oh, yeah.
headline constraint is this thing is going to get hit 100 times a day with a metal pin.
Yep.
It's like nylon, right? For that whole kind of like self-healing and impact resistance. Or if it's like, hey, this is a sign for outside, the headline constraint for me is UV resistance. So I think
Yep.
about it in
Absolutely.
that way, and then I start going to, okay, should it be filled? Should it not be filled?
Mhm. Yeah, and sometimes your applications will be very simple, and then sometimes there's, 5 different you ask for a priority list of, variables, and they are all ranked number 1 because of the intensity that you're gonna have in your environment and everything, so that can be fun, for sure, trying to kind of flex around what is and is not okay and starting to push, and like you said, a lot of times those fillers can really come in handy at that point as well, but
That's really interesting. Now, Kyle asked a great question. Okay, so we talked about, in that situation where everything is a number one priority,
Mhm,
going to something like a PPS CF.
mhm.
Kyle says he has a spool of it and he has a parts list for his machine shop, but he's not sure what ones would make sense. So I guess I'll ask this as a more generic kind of thing. Like, what are the things you're seeing your clients print
Mhm.
out that do warrant the PPA CF, the PPS CF, or even above, like peak? Give
Yeah.
us some ideas and inspiration of like, this is the stuff you can print if you have those top notch polymers.
Yeah, absolutely. We have actually had some 3D printed parts prototyped for things like airplanes, jets, space applications, which is always very exciting. We actually recently did a feature of a company called the Garage Shop, where they create it's such a cool blend of retro cars, like old muscle cars, but they push the performance limits and they do drag racing, they do very intense applications. It's very, very fascinating. And they try to push what instead of machining everything out of metal, they really try to look at what can we use polymers 3D printing for quick turnaround, but how far can we push those prototypes into potentially getting a few actual runs out of them before they break. So we have some pretty intense applications that people look at from just grit and intense forces acting on it, space applications, things like that. But we also have people that are looking at chemical resistance and dielectric constants, things like that. It's very fascinating. We have across the board. We're very fortunate to be able to work in an industry that people come to us with stuff I would have never thought of for 3D printing.
Yeah, I'm looking at your website. I guess I can share it here. Like, there's some pretty crazy stuff. Like, someone's
Mhm.
prototyped an engine block, which is
Yep.
wild.
Mhm.
Jigs, obviously, fixtures, tooling. You can see end use parts. I don't know what that part is, and I don't think you see my screen, but there's flame retardant stuff. That's pretty crazy. Okay, let's go back. I want to go back to individual filaments,
Yeah.
just because, how often. Polycarbonate, okay?
Hmm.
That's one of those that, like, I rarely find good uses for. It's strong, but it's brittle and it's not as impact resistant. Like, what? I know you guys do some great polycarbonates. What are your customers using polycarbonate for?
And you found one of the ones that I don't know too much on in terms of applications. We see a pretty wide variety of people coming in with the polycarbonates, but like you said, it seems to be very niche
Right.
in terms of what people are using it for. A lot of what I see people using it for is more just very specific chemical resistance. Obviously, it's
Got it.
not as robust as some of the other materials that you can purchase in terms of across the board, but people will have
Right.
applications where it's like, hey, the only chemical it's going to see is this, and I just need it to
Got it.
resist this.
Okay.
So that's a big one. And then, polycarbonate is a material that has been around for a very long time. It's something that people who, do injection molding have a lot of experience with. So a lot of times when people are starting to dip their toes into 3D printing, but they have more of, an industrial grade or a little bit higher grade printer and equipment, they like the familiarity of it. They like knowing the properties that that has.
Right.
So a lot of times they'll kind of step into that one first, and if that fits their application, great. Especially because if it's a prototype, and then they're going to go into an injection mold tool, and they want to eventually just injection mold polycarbonate, that's a really good medium for them. It doesn't skew their data that they have from prototyping. So we'll see a lot
That's
of
cool.
that as well. Yeah.
That's really cool. I think of polycarbonate like, when we talked about that headline constraint, it's like when I have something that's going to be thin walls, like I'm printing a bin or bucket, it's like I need those thin walls to have insane layer adhesion. That's kind of the only
Yep.
application I'm using it for, or really high transparency. Like I want something to be super clear.
Yeah.
But I think there's a reason that most of the 3D printing polycarbonates you're seeing on the market are blends, right? Because
Yep.
it's not really a perfect material for 3D printing.
Yeah,
Um,
and ours in particular, we work to make it as pure as possible, which in the sense does make it a little bit more difficult to print. But we have found, like you said, those use applications that polycarbonate calls for, ours really, shines in that because we try to keep it as pure polycarbonate as possible. So you do have some warping and such, but if it's something that you know the properties of and you're willing to take it on, I do think it has, like you said, some very important use cases that can be really fun to just play with and see what your printer can do with it.
yeah. Yeah, PC can be tough, as
Hmm.
someone just said in the chat. It can be really tricky, especially if you don't have a
Hmm.
heated chamber.
Oh
Um,
yeah.
are you guys extruding all this stuff yourselves, or is it a combination? Like, I can't imagine what a filament extrusion looks like for peak and stuff like that.
Oh yeah. So yeah, we extrude all of our filaments in-house, especially our higher end ones. So that's always really fun. Just seeing those lines, the equipment, yeah, is impressive for sure. Very, very hot temperatures and very. There's a lot that goes into it in terms of quality control. There's a lot that goes into it
Right.
in terms of just processing, like you said, those higher temperature materials can be quite the activity for sure. But we have people who have been doing this for over a decade now. I hazard to think of one I believe has been in the industry and doing this for about 20 years now. So
Wow.
they are artists on the line. It's very much a science, but just watching them walk in and diagnose a problem the second they see it is something that I am honestly very jealous of. It's a skill that is very impressive.
Really cool. Well, you'll get there, We're still
Oh
young.
yeah, yeah,
You've
absolutely.
got you've got a lot of time. So that's really, really cool. What are your clients using the most of? I wonder, because I feel like even at the industrial level, PLA is so strong. Is that still
Hmm.
for your clients kind of like the best seller?
Yeah, so right now it's actually ESD PETG and ESD PLA. We have been seeing a lot of those, and with the conductivity aspect of it and all the electronics that are, happening right now, people are pushing more and more to keep their electronics safe, or even just, really see what a conductive polymer can do. Yeah, they are flying off the shelves right now in the sense of just everyone wants to try it. It's a very cool material.
Okay, so let's go into that. ESD means that it's conductive,
It
specifically.
means so there's a range. It's a static dissipative is what we aim for. So there's two, technically three categories. There's insulative, which obviously does not conduct electricity in any aspect, and then there's static dissipative, which is basically it has enough conductivity to it that if you have an excess of electrical, static buildup, it will send that through and it will ground it. And then there is conductive. So conductive is just the free flow, open channel. We generally aim for static dissipative just because of the industry that we try to tailor our polymer to. Mainly, protecting chips, protecting electronic equipment, being able to
Right.
print packaging custom to your part and protecting it through transport, everything like that. But there is definitely a growing market for the more conductive filaments because who wouldn't want to be able to print in a couple hours something that can just conduct
Yeah.
electricity is very, very cool.
You could print your own PCBs if you have a multi-material
Yeah.
machine.
Yeah.
I think
Which
I
is
might
just
try that
insane to
actually.
think about. Please do. That would be very fun.
I need to
Yeah.
design a PCB, which I don't know how to do, but maybe I can have someone design a PCB for me and then I can print it. That could be really
There
cool.
you go. I watched someone design a PCB once and I was lost immediately. So I
Yeah.
understand. But no, and who would have thought even 5 years ago that that would be an application that someone could just casually say, oh, I'll try doing that sometime. Polymers, cool. I'll try to print a PCB.
Wild, huh?
I know.
Completely
It's
wild.
just, they,
Which, by the
yeah.
way, is a phenomenal segue for those of us who cannot print our own PCBs. Let me really quickly thank our sponsor for this episode, which is PCBWay. They can make PCBs for you, but they can also print PEEK for you. They can print resin printing for you. They can do injection molding for you. They can really kind of do anything for you. CNC machining. If you know those peaks and pecs are not strong enough, you could get some titanium machined. They give you a $5 coupon with the link in the description. I use them for any kind of CNC stuff that I need, and they're just wonderful to work with. One of the things I love about PCBWay is they have a real-life engineer look over every single order. They don't just send it out, and then, if it warps or something isn't strong, they'll actually tell you, hey, are you sure you want to design it this way? Which is a lifesaver for folks like me who don't know how to design PCBs. So thank you, PCBWay, for that awesomeness. I wonder, Rachel, what are some of the common mistakes that you see and things that you're always telling customers, like, hey, you probably don't want to print this out of this, or hey, you probably don't want to do that? Like, what are some of the kind of common issues that you see that we can use to kind of educate our audience?
Yeah. Um, well, I would say jumping into a filled material, like kind of touching back on what a previous conversation that we had, jumping to a filled material where maybe your application does not specifically require it can sometimes be a little bit of an issue, mainly because, those filled materials are more brittle. They are a little bit more difficult to print in some cases. And so that can just be a little bit of a headache when you're trying to print that. And if your application doesn't necessarily require it, the extra, money that you have to put up for that material and the extra difficulty in, something snapping in a Bowden tube because it has a little bit too much of a turn to it when you have a 30%
Right.
glass fill can be just a headache. Other than that, I would say, not taking into account all of your application aspects. If you don't remember that it's going to be sitting outside all day, every day, you can sometimes pick the wrong material on that. Or sometimes also, I found, heated chambers are always important when you get into those higher temperature materials, the high
Yes.
warp materials. And not to push on one of your videos that you made recently, but drying filament, depending
Yes.
on the type of filament, can definitely be important. And we will see some customers struggle with that. And if you don't know what you're looking for in terms of moisture content, it can just be a sort of a ghost in the machine. It can be really
Yeah.
confusing why one day your prints are gorgeous and the next day they're not even adhering to the layers. So that
Totally.
obviously can be a larger conversation. And I did like the testing that you did. You did
Didn't
not
work
need
out
to
so great.
undermine. Well, testing is never. We go to our ASTM testing standards for tensile and stuff, and sometimes I still feel like we mess up once in a while. So, but
Did you find that on the whole, most like basically my takeaway was, nylon and PETG have to be
hmm
dried.
hmm
PLA, ABS, and ASA, kind of not really. Like, I'm sure on the label you guys recommend to dry all filament, but
hmm
in practice, is that more or less what you guys have found as well?
yeah, it's always very a good step in troubleshooting whenever you have a printing concern or you're not getting the quality that you're hoping for. But there are definitely cases where you don't have to worry about moisture as much as some people do. But if it's always good practice,
Yeah,
it's like drinking a little bit of extra water every day.
sure.
It's not gonna hurt you. It's just a positive. But the only thing is sometimes you can over dry materials. So
True.
there's definitely two sides to that coin. But on the whole, I do think it is important to dry materials,
Fair enough.
depending on the specific type that you have. But it's definitely not something where 30 seconds out of the bag you're
Right.
losing precious moments. So
Right.
I would say also very dependent on the specific grade, the specific manufacturer of those filaments as well. Any additives can very much alter how much moisture that material wants to absorb. So that's always something good to keep in mind, which
Okay.
can be a little difficult when people don't share, the breakdown of those additives that they have in there, but that can definitely play into it. On your video, there were a couple comments where it was like, oh, this specific brand of PLA, I have never dried it and it's gorgeous.
Right.
And then this one I've had for 2 weeks and it's already looking like there's some moisture issues. So very much, I think, dependent on the grade and the additives that you have in it. So
I found that too. I found like certain brands of
mhm,
PETG I couldn't get to soak up water, and other
mhm,
brands just were terrible out of the box.
mhm,
That's a good segue. A ton of people, like half the chat, is asking about
mhm.
PCTG. I've only recently started experimenting with it myself, but give us the
Mhm.
lay of the land with PCTG.
Oh gosh, you guys are asking such good questions, and I am very much, you're hitting all the ones that I'm like, I have it, and I cannot for the life of me remember it right off memory recall. So let me
Well, it's
super
a
quick
newer
pull that up
material. Like,
for me.
I never heard about it until like 2 or 3 months ago.
It's
Um,
definitely something that's starting to come into the spotlight for the first time. It's something we've offered for a decent amount of time, but it's really having its day in the sun, which is fantastic. So, uh, you know, it's a pretty solid material. It really is one of those ones that's sort of taking your first steps beyond the typical PETG, ABS, ASA, PLA, and really starting to push more into the engineering side of the filament world, which is super exciting. It does not have very intense print requirements, which is always a positive. And it not a lot of moisture absorption, which is a huge
right.
positive as well. So
Compared
that's always a
to
big benefit.
obviously
Uh,
PETG. And then
yep.
even I see on your website even superior chemical resistance to ABS and
Yes.
PETG, though PETG is considered pretty chemically resistant. Is
Mm-hmm.
it is it fair to say, I won't put you on the spot with like the actual
No, you
tech
are
specs,
all
but
right.
is it fair to say that it's kind of just a better PETG in every way? Because that's what it sounds like.
I think that's a safe, blanket statement to make. It has that edge to it that PETG, you have the beginnings of some of those properties that you'd look for, but yeah, PCTG just takes it to the next level. It really, it's just, yeah, it's a good all around filament to use. It has good balanced specs to it. It's not a super intense material in terms of printing. So yeah, it's just very approachable, but it has some pretty robust use cases. So.
It almost sounds like it's the ASA to PETG's ABS, like just a better all around newer. But I wonder, is it because it's newer and more expensive that it hasn't caught on in a bigger way? Or is it going to be the case like we're seeing with ASA versus ABS, where 5 years from now, people are going to be printing it as much, if not more, than they are PETG?
I've seen the industry start to shift more, yeah, toward the PCTG. I think it's just a material that, like you said, up until this point wasn't necessarily in the spotlight, and people like to use what's familiar. They like to
Right.
use there's resources online. There's decades worth of Reddit posts on
Sure.
PETG, and then yeah, you move into a new material that you maybe don't have profiles from your printer manufacturer or anything like that.
Right.
Totally uncharted territory, and the time that takes, especially if you're running like a small business where the turnaround is paramount, you don't necessarily always have the time to experiment and to play around with that. But I
True.
do think as more people start to use it, I think people are really going to start to find how valuable it is as a material. And I do think with limitations of cost, everything like that, that it will start to be, like you said, just about as popular as ASA versus ABS now.
Yeah, I got the impression that a lot of filament manufacturers want to move away from ABS and into
Mm-hmm.
ASA because besides cost, there's kind of no reason anymore to print ABS.
Yeah, yeah, and it definitely has its use cases. And like you said, cost can be a very valuable thing if you're just starting to
Right.
get into 3D printing. I like to say that ABS has just enough temperamental in its nature to really put you through your paces if you want to learn 3D printing and you want to learn troubleshooting. But yeah, ASA has some very nice benefits that, yeah, it's my go-to for sure.
Yeah, the only downside I've seen with ASA is certain brands have a bed adhesion issue. I like to use Magigoo's PC product, and that solves it right away. But ABS will stick to any surface, whereas ASA I've found doesn't stick as well. For folks wondering, I'm going to try and butcher this name. PCTG is polycyclohexylinidimethyline terephthalate glycol modified.
Just
So
about as
it-
well as I would have pronounced it, so you're good.
So it's actually chemically, it's a kind of totally different thing, right?
It's the terephthalate and the glycol definitely are
Right.
characteristic of the material. So, but you know, it's very similar to PEEK versus PEC if you want to get into the high temp materials. Just the one letter can make a significant difference in terms of, you
Right.
know, amorphous versus semi-crystalline properties and the temps that it melts at, the chemical resistance that it has. Then you start getting into the polymer chemistries, which I find
Right.
fascinating, but also can be very intimidating. So
Right.
um, it definitely, yeah, it only takes one or two components or even amount of that particular chemical in the chain to make some pretty significant differences in behavior.
Yeah. I found, I wanted to mention, I found on the PCTG parts that I printed, I found
Mm-hmm.
them to just be a little more flexible than PETG,
Mm-hmm.
but otherwise they behaved like PETG.
Mm-hmm.
And I guess that flexibility is the superior impact resistance they're talking about.
Yeah, absolutely. And then obviously you see the more molecular side of, like you said, chemical resistance, heat deflection, things like that, that you don't necessarily see right away in the behavior once it comes off the
Sure.
printer. But that can be a huge part. Even just seeing how those molecules can intertwine and interact based on the shape of them can be a huge change in the behaviors as well.
Cool. Okay, I have an idea that I want to pick your
Uh
brain with. So I'm working on a video about using multiple materials and multiple
oh.
nozzle sizes within the same print. And I'm
Oh,
trying to
wow.
find interesting use cases and applications, partly because Prusa Slicer just added this ability to print within one
Yeah.
print. You can have a zero 0.4, 0.8. One of the things I was thinking about, and I wanted to ask an expert, so that's what I'm doing now, is, they always say infill is really, excuse me, infill is really not adding strength. Infill is more about supporting the future layers that you're printing. So I was thinking to myself, like, okay, if you're printing something out of a PEEK or a PEC or even a PACF, and you don't want that part to come out costing $300, could you? I don't think PLA bonds to PA. PLA only bonds to itself, I'm pretty sure. No, that's wrong. PETG. Anyway, my point is, what do you think about the idea, to give me honest feedback here, of
Mm-hmm.
using just cheap, normal nylon as infill and then using carbon fiber nylon on the outside for the dimensional stability and the temperature resistance and the strength? Or is it like
Interesting.
not worth the money savings?
I think it would very much depend on your application and like what chemicals or what environment you're going to be seeing with that part. One of my concerns, just right off the cuff, would possibly be you are going to have some moisture absorption after printing, and nylon
Right.
does tend to swell a bit after printing. So depending on how tight, you know, how small that part is, how much infill you have, you might have a little bit of swelling from those internal components that might, you know, if you really
Yeah.
push that, might actually cause some layer cracking on the exterior because it's going to have a different rate
Huh.
of swell than the external parts.
Even if
But
the you're saying not pure nylon versus carbon fiber nylon will have different rates of swell?
yeah, so the carbon fiber helps to reinforce like the dimensional stability aspect of
Got
the
it.
material. So you're going to see, you know, it won't be a massive change, but it might be enough to cause some material cracking. So
Interesting. Okay. Huh. I'm racking my brain
But
trying to figure out ways to like uniquely
yeah, that
combine
would be
different
a
materials.
really interesting. Yeah. No, I could definitely see the cost savings of using a different material for infill to potentially, if you have, like you said, a compatible material and something that you know hits the immediate mechanical needs of your application. I feel like
Yeah.
that would be a really interesting way to take that.
Well, and
Huh.
I also wonder, again, like we said, most of the part's strength is should be coming from the shells. So
Hmm.
even if you just infilled with anything, PLA, right? Like, does it actually matter? Obviously, for final production part, no. But like for testing a prototype, is it true? I mean, this would be the thing to test. Is it true that infill really is only providing support for the future perimeters and the top layers? Or is it providing more strength than we realize?
That is a really interesting thought. My immediate knee jerk reaction, just not having read that before, would be that infill does provide strength to the part, but that I want to know how much. I want to hear that. I want to see the data.
Yeah.
Please show me the data. That would be wonderful. Yeah,
Yeah,
because
but
I,
as I
I guess
always
I've
say,
never.
my name is not Stefan, and this is not CNC Kitchen. Um, what do you think is a good? Okay, so if someone in the audience has printed PLA and PETG,
Hmm.
back in the day we would say, okay, it's time to graduate to ABS, but now we have so many other
Hmm.
polymers.
Yeah.
What's a good next step for them to try out? Is it PCTG? Is it ASA? Is it PETG-CF?
I think it would be fun to really start to dip your toes into some filled materials. I feel like that would just be seeing how those fills, I feel like the knowledge that you would get from that would be very, very valuable. Just understanding how, even within that same polymer, the base resin, you can so drastically change some of those behaviors and the characteristics of the part just by
Right.
adding some fills. I feel like that's very valuable across the board, just in your
Agreed.
understanding of 3D printing. And then also how, it reacts in your printer, how there's, a little bit more difficult to get good layer adhesion just because, like we talked about, those filament fillers kind of become a little bit of a disruptor for the molecular chain bonding, things like that. I feel like that just would really push your knowledge of the mechanical side of 3D printing, but also the polymer side, and is
Totally.
something that you can really use carrying forward into pretty much any material that you use.
Totally. It's kind of like a meme on the channel. It's a big part of the next layer canon that I hate PETG, and I want to like at some point have shirts made with a little asterisk. Like friends don't let friends print PETG, and then there's a little
Yeah.
asterisk because I feel like everything I hate about PETG is completely ameliorated by adding 15 to 20% carbon fiber, and
Yep.
suddenly it's like the best material here. Someone just said replica, literally as I was saying it, said PTG CF prints so much better, significantly less warping, not even talking about
Hmm.
texture. Yeah, it's
Hmm.
it's fantastic. Colin says he's going to pick up some PCTG. I think we put a coupon. You guys were very generous and gave a coupon code
Yeah.
for members of the audience. So there's a link in the description and I think a coupon
Hmm.
code. Uh, so thank you
Yes.
guys for that.
Yeah, Joe,
Another
what's
thing I
our
want,
coupon code?
yeah, let's put it
The
on here.
next layer. Yep, the next layer. I would assume in all
Coupon.
caps. We like our caps around here, so.
You got it. Um, do the glass fiber filaments also need strengthened nozzles, like hardened nozzles, or are they a little bit more forgiving than the carbon?
Yeah, anytime that you have a filled material, it puts excess wear on your nozzle. So I would definitely recommend getting a hardened nozzle anytime you start to dip into the filled materials. It just can really want to chew through things. So
Right.
yeah, regardless of glass or carbon, I definitely recommend a hardened steel nozzle.
Now I'm curious. You guys are obviously based in the U.S., so you may have a
Mhm.
preference towards U.S. manufacturers, but clearly you guys print an absolute crap load of fiber-filled materials. Like, what are the
Mhm.
nozzles that you guys are using, and what are the ones that you found hold up the longest or the best value for money?
Oh gosh. Oh, that is not an answer that I have off the top of my head, unfortunately. I know we
Okay.
try to get a good variety, just because we want to understand, how it conducts heat. We really try to, both in our printers and then the accessories that you can get aftermarket, we really try to get across the board as much as we can so we can understand, whenever a customer comes to us with their equipment specs, we can try to have some level of experience with that so we can better understand how our materials behave. We're always looking to learn and try to keep up with the market as all these new printers come out that have more and more capabilities, just so we can understand, how our materials perform on each of those and really try to meet our customers where they are.
Fair enough. I'm going to also answer the question for myself, which is you guys are resellers for E3D and also Diamondback. So I assume that you guys are running in your print farm or in your prototyping, probably E3D Obsidian and Diamondback nozzles if you're selling them.
Those are definitely in our portfolio. Yeah.
I like my Diamondbacks. I obviously, get them. They're very kind and they sponsor them, and E3D sponsors them. But I think, before I was getting stuff for free, which thank you guys for watching and making it possible that I get all this stuff for free. But even before, I was spending so much on nozzles and just swapping them. And even they get clogged and you're like, it's only a few bucks. Am I going to spend? Today I spent 45 minutes because on a specific printer I'd run recycled filament through, and my recycled filament is trash. And I spent like 45 to an hour unclogging the nozzle on that. And then I looked at my kind of billable rate, like if I do a live stream or something, and I was like, this nozzle just cost me like $300 or whatever. It's like, so my point is, I generally tell people, like, if you're going to print a lot of carbon fiber composites, like, do you want to buy 5 nozzles over the next 5 years that are hardened steel, or do you just want to buy one really good one? And especially as Jacques said, if you have Revo on your printers and you're swapping it between. Cool. What's something that I should have asked you that you were excited to talk about that I did not ask you?
Oh gosh.
That's a tough question to put people on the spot.
Yeah, I was going to say, it's a question of a question. I was going to say, I'm just a geek in general on how the industry's moving and where we're pushing things. And so I'm always up for talking about that. But in terms of specific questions, you hit pretty much all across the board. That was good.
That's fantastic. What's kind of the innovation that you're most excited about right now that's happening in the industry? Is it, the faster printers? Is it the more intense polymers?
I definitely like seeing people push to have higher performance materials on lower cost equipment. I think that's huge. Having people have more access with more ease of, equipment, time, money, just being able to really find some of these higher temp materials and really be able to push their applications from, more. I came into the industry when it was still mostly printing knickknacks, just nice things to put on your shelf. And the fact that you can now, in theory, print Altem 1010 in your basement if you really want to is amazing.
I have a printer off camera here that allegedly can print Peak.
Yes.
Which is crazy. Excuse me. It's like a $700 printer, and it can print Peak. I haven't tested it yet because I managed to destroy the silicone sock, which you really need if you're printing at 450C. But that's crazy to me. That's absolutely crazy to me. I'm going to open it up to the peanut gallery with the remaining couple minutes we have. You can tell my cold medication is starting to wear off, but Gerari
I have an
wants to
allergy
know
right now.
Oh yeah. Gerari wants to know, do you think in the future 3DXTech might offer a filament sample pack for purchase? It would be really helpful for folks like him in finding the right filament for the project.
Yeah, we have definitely discussed that quite a bit, actually, because we do want to be able to. There are some applications where it really depends on what you're going to see, and sometimes you don't always know the factors that are going to go into it, and we want to be able to give you guys the most opportunity you have to succeed in your application and your project. So we have definitely talked about that, and I can definitely bring it up again because that sounds like a great idea.
Rock on. Gerari also asks, for prints that have to hold weight, like 3D printed bins holding bolts and screws, what would be the optimal material for hobbyists to use rather than PETG?
Okay. Yeah, I would say you definitely want to look for something that you print orientation is important too, but something that you definitely know is going to have good layer adhesion, I think, is something that's important. So, I'd almost say, depending on how many bolts you're holding it with, and see, that's where I get to in my engineering product
Yeah.
design aspect. They would give me the weights, and the sizes. But I would definitely say just something that you make sure has good layer adhesion, get some, multiple print layers in there, multiple shell layers. And then I'd say you could probably just go with more of a commodity plastic, maybe, ASA. If you have a small bin, possibly even just, a PLA if you're not planning to slam it around.
Right. I've actually found, shout out to Ahoy from our Discord, because I've actually found with ABS specifically, I didn't try ASA, I was printing a huge planter, and it had very thin walls, and I thought, ASA, ABS is good, all this stuff. And it kind of fell apart the first time I hit it, which you think ABS, good resistance. He was telling me, like, ABS is a really, really great material for injection molding. It's not designed to be very thin. And he had me do PLA. But it wasn't, the planter wasn't holding weight, but PLA I found for thin walls was stronger. I actually went to, without question, PC, if you can print it. Because when I print, I print these little like IKEA style bins, really thin walls, 0.8 millimeters, and they'll hold weight. But
absolutely
hard to print.
Yeah, yep, definitely a little bit more difficult to print. So if you're looking for more of a commodity, I'd probably say PLA. You could get away with that. And it all depends on your design too. You add ribbing, you add a few, extra aspects of the rigidity, and make sure that everything's going well in that side of things. You're going to see a lot more success in your prints, depending on, what polymer you choose. So
yeah, really cool. What's the printer that you're going to if you just need something to print? I don't know what you guys have around, but like if you just need something to print, what's the printer that you're turning to?
Oh gosh, it really depends on what polymer I want to get into. We play around with a lot of our higher temp stuff, just for continuous improvement and to test on, things, make sure what we're providing is what we say we're providing. And it's just, fun. If you have access to 1010 on a daily basis, you're going to use it. But I would say I really try to keep as up to date with printers as I can. So I try to use as many as possible. And I don't really have one that is really secure in my heart as the number
Fair
one
enough.
spot. There's so many.
Okay, so
coming out
go-to
that are
material.
awesome.
If you're like, it's the end of the day, 5 minutes to 5, you need to print something out that you need tomorrow. You don't want to mess around, and spend an hour planning the right thing. What's the material that's just your all-around go-to? I feel like this is a very hard question for you.
Well, you have so many in your, in your head, that, am I allowed to, I think if I had to pick one that's just fun for me, our ESD Ultem 1010 is so fun, and it prints beautifully. It has just such a nice surface finish, and the parts, having a part that doesn't need to be static dissipative, but is very fun.
All right, so let's see. PEI Ultim 1010.
ESD,
Holy
yep.
crap. This is a hell of a... It's actually not that expensive.
No,
a 1 kilo
we do our
spool
best.
is $4.95, which may sound outrageous to people, but like a roll of the cheapest Chinese-made PEEK is $1,000 a kilo. The cheapest stuff that I've found on the market. So $500 for Ultim.
Yeah, and we use carbon nanotubes as well. So we do our best to get that performance really push. So I know we just want to optimize and have it, be as engineering as possible. But that one prints beautifully. You wouldn't expect it to with how high performance it is and the fact that you have a filler in it, but it just turns out gorgeous. Otherwise, I'm always a sucker for the carbon filled, just carbon fiber PETGs, carbon fiber ABS, everything like that. Just the finish looks great.
This stuff actually isn't that crazy. I've never printed PEI. But it prints at 360 to 390, not some, peak you need minimum 450. That's like doable. The drying is hard, 120C. You would need a pretty serious dryer. Bed temp. Yeah. Okay. Okay. Never mind. The bed temp is tricky. 140 to
That
160.
bed
Yeah.
temps and chamber temps are where I think a lot of people underestimate exactly what that takes to get a good, beautiful part that doesn't have layer adhesion issues when you get into those higher temperature materials.
And you could literally print your own print beds with this stuff. It's so cool.
Yeah, it's very, very cool. Yeah. Oh, we have a few printers that have some functional 3D printed parts where you probably wouldn't expect to have some. It's very fun.
How
So,
do you get this stuff to stick to the bed?
typically we use like a nanopolymer adhesive,
Okay.
things like that. We do have, oh, I can't remember the brand off the top of my head, but there's one specifically for the very high temperature applications that we've seen good success with our PEIs and some of our peaks as well.
Right.
So they do exist, and yeah, that's the easiest way to do it. And then just making sure that your chamber and your bed temps are where they need to be, so you don't have any excess warp to pull it off, is really
Yeah.
important. So
Yeah, I've got some of the Magigoo HT, and I think Vision
yeah,
Miner Nano has an HT as well, or is rated for
yep,
HT. Well, this
yep.
has been a lot of fun, geeking out with you on materials. We'll link in the description to your guys' website. And I really appreciate the time and you answering questions. And I hope we get to geek out at a trade show sometime soon. Thanks for coming on.
Yes, yeah, we have Rapid coming up in April in Detroit. We'll be there. So anyone in the Midwest area, feel free to stop in. We'd love to chat. I'll be there and I'll be happy to geek out. So
Awesome. All right, guys. Thanks for tuning in. And I will take us out.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know. And consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on The Next Layer.